and welcome to Morse's Math Morsels. Here we have the binary base 2 system and accompanied by some powers of 2. The binary means pertaining to 2, or the number 2, things that happen in 2's. And our usual base 10 system, the numbers we're all familiar with, are based on powers of 10. For example, the number 284 is really 2 100s plus 8 10s plus 4 singles. Or the number 16 is equal to 110 plus 1 6. Well, these examples, I'm going to convert each of these 5 sample numbers in our ordinary base 10 system into the binary or base 2 system. And to do that, I'm going to use some powers of 2. Notice I've written them in descending order. I'm going to start with the largest power of 2 for these examples, and note that each power is twice as much as the one to its right. For example, starting at 1, if you double it, you get 2, the next power of 2. If you double that, you'll get 4, the next power of 2, and so on, continuing with the 8 and the 16, doubling all the way up to 256. So the method asks the questions, how many of each powers of 2 are required to make up each of these 5 sample numbers? I'm going to start with 29. So the method is find the greatest power of 2 that is equal to or less than 29. See, it's not quite 32. 32 is just a little too large to fit into 29, so we need to go down to the next lower power of 2, the 16. Since we have a 16, I'm going to write the digit 1, and this 1 will represent 1/16. And then take 16 from 29 to yield 13. Having accounted for that power of 2 of 16, we now just need to consider the 13 that is left. The next lower power of 2 is 8. Can 8 fit into 13? Yes. So we can fill in another 1. And take 8 from 13, leaving 5. And 4 going to 5, yes. 5 is large enough to accommodate 4, so I'm going to insert another 1. Taking 4 from 5 leaves only 1. Can the number 2 fit into the 1? No, it cannot. So we need a 0 as a placeholder. We cannot use the 2 because the 2 will not fit. Finally, the 1. We have 1 left. Hence, 29 base 10 equals 11101 and base 2. Well, that 11101 really means there is a 116, we have 18, we have 14, there are no 2's, and there's 1. So add these powers of 2, 16 plus 8, 24, 28. 28, still stay 28. I started the add to 2 and say, nope, there are 0 2's. And add the 1 finally for 29. So far, so good. Next example is 78. I'll leave this on there a few more seconds, and I'll erase it. '78 needs a 256 or 128. Nope, those powers of 2 are too big. Let's go down to the next lower number, 64. Yeah, 64 will work. So I'm going to put a 64 to the side. And let's take 64 from 78. That leaves 14. Oh, we have a 64. How about 32? Well, 32 is too big to fit in 14, so we need that placeholder 0 again. About 16. Use 16 as a power of 2. Nope, that's still too big to fit into this 14. So we need another 0 as a placeholder. Have to go down to 8. yes, we can use 8 as a power of 2, and we can put a 1 here representing the 8. So we have 6 left over. And the 6, yeah, we can accommodate the 6 with the 4 and a 2. And taking away the 4 and the 2 is a 0, so we don't need any 1s, so we just need the 0 placeholder to fill that 1 spot. And therefore 78 in base 10 is 1001110 in base 2. I'm going to check that to kind of recap. This 0 means a number of 1s, this 1 means a number of 2s, so we have a 2 that's added on. This next one's the next power of 2, that's a 4. This one is an 8. These zeros are placeholders for 16 and 32, which were not used. They did not fit. And this one is a 64. So just add the 64, the 8, the 4, and the 2. 64, 72, 76, 78. Well, there's our base 2, or binary for 78. Continuing in like fashion for the remaining 3 number examples. 113, can't use 128, gotta go down to 64. That leaves 49 left over. Go with 32. We have 96 so far, we have 17 to go. Well, so far we have a 64, a 32, and a 16 that equals 112, so we just need a single number, that single number 1. So ignore the 8, the 4, and the 2. Finally, the 1. So that's a 1 plus a 16 plus a 32 plus a 64. 96, 112, 113. 192, when you work it out, that'll be 128 and a 64. And, oh, that sum is already 192. 128 plus a 64, so I'm going to have zeros all the rest of the way. There'll be no 32s, no 16s, no 8s, no 4s, no 2s, no 1s. Now 192 comes out to a very, very round-looking binary number, requiring just the 64 and the 128 and no other powers of 2. And finally, 443, our largest number, if we were to work that out. I'll leave it to prove to your satisfaction that 443 is indeed equal to this number in binary. And by coincidence, it's a palindrome. Reading it forwards is the same as backwards. Backwards and forwards, it reads the same. So that was an illustration of expressing numbers using the binary system, powers of 2, and using as many of the powers of 2 as are required, and getting the powers of 2 to fit within each decimal base or base 10 number. Thanks for viewing.